Okay, here we go on the last question then. So we've got this function of x, and what it's looking for is the exact value of each of the zeros of f. Wording is a little strange, yeah, I admit that. Essentially what we're looking for are where f of x equals 0. So we want f of x to equal 0, or where we have the roots of our equation. So let's set our equation 0 is our function of x, 2x plus 2, 5 minus x squared. And we know when something's in its factorised form, which it is here, we can just set each of those brackets equal to 0 and solve. So the first one we get 2x plus 2 is equal to 0, and x equals minus 1. Second one we've got 5 minus x squared equals 0, add x squared to both sides, and then we square root them, leaving us with root 5 is x, just remembering that we've got plus or minus. Now we want to leave it in this form because it asks for the exact value, so we don't need to plug that in to our calculator at this stage to work out what it is. Okay, next we need to expand our function f of x. So if I take my function f of x, bring it down here, and we're basically going to look to multiply everything out. So this times this, this times this, this times this, this times this. And we can do a little smiley face with some ears. And an extra mouth under there. Kind of. Anyway, make sure we multiply everything out. So 2x times 5 gives us 10x. 2x times minus x squared gives us minus 2x cubed. What else are we going to have? 2 times 5 is 10, and the one that I haven't done so far is going to be 2 times minus x squared gives us minus 2x squared, and there we are, all done, nice and easy. Okay, moving on. Using the graph paper provided, oh, that's a little cue for me. Using the graph paper provided, draw, important command word there, draw, and we all know draw from up on the classroom, represent by means of labelled accurate diagram or graph using a pencil. A ruler should be used for straight lines, diagrams should be drawn to scale, and all of this business. So that's what we want to do, and so we need to make sure we do our axis first of all. So I'm going to come down here. In fact, I'm going to take my function of x with me, which I had somewhere, didn't I? Oh, that's grouped together. I'll get another one. So our function of x is this one. Let's take this with us, and we'll start to draw it down here on our provided graph paper. Okay, so I've just drawn with a ruler roughly what sort of thing I want. Now I know I want it to go down to minus 3. So there's 1, minus 1, minus 2, minus 3. Just being careful I get the scale consistent. And the same out the other side. At 1, 2, 3. And going up, I need to go to 20, so I might have 10, 20, 10, 15, 20, 30. Oh, just about fit that in. To go 5, 10, 15, 20, minus 5, minus 10, and just making sure that I comply with what's being asked of me, which if we refer back to the question is that we're going from, on our x's are going from minus 3 to 3, and our y's from minus 40 up to 20. So now I've got that on my axis, I can now think about drawing it and looking at what this looks like on my GDC. Okay, so I insert this into the GDC, and this is what I'm seeing. a nice curvy graph, lots of kinks in it. What we've got that's of interest though, what I've done on this display is I've pressed Control and T, and it gives me this table here, which enables me to see X and Y values, and you can see here that I can scroll up and down and see lots and lots more. This gives me the facility to be able to plot points on my graph, which we have to do in this case when we're, as I say, drawing instead of sketching. So let's just get all of that, rid of that annotation. I'll take my GDC, move it across to one side. Where's it going to go? Just here. And I can start to plot. When I'm plotting the points, I should get something like this. We should get -315, and I've got that just from scrolling up. You can't see it here, it's not an interactive, it's just a screenshot. -2 falls just below the axis. -1 is bang on, we've already solved that. Talking of solving, we had -√5, which is around here. We've got 10 at 0. 1 gives us about 16, which I can just about fit on with my GDC where it is. 2 is just about on 8. 3 is well below the axis, that's going to go down to -32-ish. So, oh sorry, did I say 2 is clearly at 6 and 1 is at 16? Yeah, so this is where I'm getting these from, and we had that point down here as well. And do go through the process of drawing this table on your graph, and then from there it's just making a nice smooth curve. Not very smooth, is it? I'm trying my best. And we can mark obviously this point here as being √5. This one was -√5, which is quite a nice touch just to finish things off. Okay, that one's done. Finally then, the graph of this function intersects the graph of f, write down the coordinates. So again, reach for your GDC. First thing you're going to get is this image, and then following from that, you're going to analyze the graphs, find the points of intersection, and then you obviously trace between those two values here. It's here, I should say here somewhere. So let's just do that. And my GDC now looks like this, which means I can simply quote these values: 1.49, 13.9. So if I clear these out, let's get rid of it. Can I get rid of it? There we are. What did I say? I can't even remember now that I've got rid of it. 1.49. So my coordinate is 1.49 and 13.9. And there we are.